Hi guys, I'm going to try and give you kind of a quick summary mostly of how chapter 6 is going to work, at least the first two sections. So let me set this up so I can write on it a little bit. We have talked about the normal distribution before. If you remember, we talked about this, it's like in chapter 2 or chapter 3 when we talked about the empirical rule. And the empirical rule, just to kind of refresh your memories, told us that if you put the mean in the middle, right, so your mean went in the middle, and you go down one standard deviation or up one standard deviation, you end up with 68% of your data. This was the empirical rule. 68% of your data fell within that range. And then if you go up 2 standard deviations, so you add 2 standard deviations or you subtract 2 standard deviations, this range held 95% of your data. If you notice, that's most of our picture, right, is in that range. And then if you go out 3 standard deviations all the way out to here, 3 standard deviations, that range covered 99.7% of your data. And so that's how we would answer questions. They would say, you know, what percent is between here and here, and we would say 68%. So now what we're getting at are going to be problems where it's not necessarily lining up with these endpoints. Let me get this all cleared out for a second. If I line up with those numbers, then you know the answer is going to be either 68, 95, or 99.7. But what if I asked you what percent is between, let's say, this line at negative 0.5 and this line at 1.5? The empirical rule didn't have a percentage for us to memorize for this area. So what we're learning is how to find the area when it's not one of those three, 68, 95, or 99.7. And so this is where our calculator comes into play. Now, again, I'm assuming when I make this video that you have already, that you have already watched the videos and looked at the PowerPoints a little bit, so I'm not going into a ton of detail here. I'm just showing you kind of a quick summary because I'm limited in how much recording time I'm allowed to do, so that's kind of why. So to find this area, because this is normally distributed, it's a bell curve, it's a normal distribution, we go under the distribution option, DISTR, distribution, and normal is right here, and we always want to use NormalCDF. We always want to use NormalCDF. So it's going to be normal, ooh, that was ugly, CDF, and the inputs here are going to be your lower bound, your upper bound, your mean, and your standard deviation. Okay, so in this case, just the problem that I made up here, my lower bound is negative 0.5, comma, my upper bound is 1.5, comma, my mean, because this is the standard normal distribution, my mean is 0, and my standard deviation is 1. That is true because we're in 6.1, in 6.1 we're dealing with the standard normal distribution, which has a mean of 0 and a standard deviation of 1. So this will always have a mean of 0 and a standard deviation of 1. Let me pull this back up correctly. Okay. And so we hit enter, and it's telling us that that area is that area is 0.6, what was it, 625, or that would be 62.5% if they want a percentage. They might want the probability or the percentage. So that's the difference between what we're doing now and the empirical rule. With this, I can literally do this for any kind of region I want, any region at all. The other thing that I want to show you, let me get a new picture. If we wanted to go, let me see. Okay, so let's look at this one. So they want to know the area here that is less than 1.27. So our upper limit here is 1.27, but our lower end does not have a limit. It keeps going this way forever and ever and ever and ever. And so if I'm putting this in the calculator, I'm doing NormalCDF. My lower limit, since I'm going left forever and ever and ever and ever and ever, I'm going to just use negative 99999. It doesn't even matter how many nines I do. I'm just doing a really big number far to the left. So it's, since I'm on the left here, I'm using a negative, but I'm doing 99999 just to represent going this way to the left forever. Up to my upper limit is 1.27. My mean is 0 and my standard deviation is 1 because I am using the standard normal. It also told us on the previous slide the mean is 0 and the standard deviation is 1. So if I do that, I get 8.9, and this would be 8.0 if I rounded it, right? I'm getting the exact answer that they have. They have the answer here, right? I'm getting that answer. I'm just showing you how to get it in your calculator. So sometimes if you have a lower limit that goes off forever, or even if you have an upper limit that goes up forever, you'll have to do 99999 for the upper, or negative 99999 for the lower. So that's 6.1. In 6.2, it's literally the same thing, but the mean and the standard deviations are going to change. So like, let's look at this example here. Can I write? Yes, I think I can. Okay. It says heights of men are normally distributed with a mean of 68.6 and a standard deviation of 2.8. It says find the percentage of men who are taller than a shower head at 72 inches. So my shower head is, over here at 72 inches, and the men that are taller are going to be on the higher end, right? 72 inches and taller. So if I want to know what percent that area is in my calculator, I'm doing the same thing, NormalCDF. My lower limit for this area, the lower end is 72. And the upper end goes up and up and up and up and up forever. So we go 99999. Then, instead of using 0 and 1, this one has a mean and standard deviation that's different. It's 68.6, and standard deviation is 2.8. And that's it. It's 0.1123, or that would be 11.2%. Okay? Alright. Let me know if you have any questions. I just wanted to kind of give you a summary that showed how to use your calculator. You do have videos for this section, But the videos are going to focus on using a table in the back of the book, and you don't have to use the table. This is what the table looks like. You don't have to use the table because you have a calculator. Let me say that again. You do not have to use the table because you have a calculator. In 6.2, they go through a process where they convert the standard or the normal distribution, they convert it all to z-scores so that it's a standard normal. We don't have to do that because we have calculators. This is going to be one of those where the view and example is going to do things the long way. But if you go into my PowerPoints here, I give you instructions on how we can do it an easier way, right? I give you calculator instructions. So please take the time to learn how to use your calculator because I promise it's going to make your life easier. If you have any questions, let me know.